Hello everyone, I am Siddharthan. In this video, let's discuss how we can build a no-code machine learning model training web app using Streamlit, where the user can select a dataset of their choice and give some of the basic information such as what's the target column should be, what's the scaler, whether it's a standard or min-max scaler, and what's the model on which the data to be trained, and just a name for the model file. So once we have all this information, the user can click this train the model button, and then we kind of train this model in the backend and give the accuracy score. So in this we also do the process such as imputing the missing values, applying one-hot encoding and stuff like that. So the main purpose of building this application is to let people who don't have, let's say, Python skill, so they can be like business people or others who don't actually need to understand coding and stuff, but let's say they want to try this machine learning model training thing, so that we could enable them in order to use this and try it out. So that's the main purpose of this, and also in order to automate the process of kind of training the models. So that's the purpose of this video, and let's understand how we can do this. So first thing is we need to set up this Streamlit user interface, and for this I'll be using this main.py file, and we have this yaml underscore utility file where we have all the functions required in order to read this data, pre-process it, train the model and evaluate the model. So this is like the code structure that we will follow. And for the folder structure, I have this folder called as data, where I have like a list of dataset files like this diabetes.csv, and also the other version is Excel file, and we also have like another CSV file that is for this art disease prediction dataset. And then I have this src folder, the source code folder, where I have this main.py file and YAML utility file. This check.py file is nothing but if you want to just try some code, for that purpose I've kept this particular file. And apart from this, we also have this trained model folder, where the trained model will be saved here with the name that the user has given. So this is the folder structure, and I'll give the GitHub link for this particular code repository. You can kind of fork it and you can like try this out. So now let's understand how we can build this main.py file and the YAML utility in order to build this interesting application, right? And the other thing about this data is like it doesn't have to be a folder. So here what we are doing is basically displaying all the files in that particular folder. You can also choose this art.csv and you will see the sample of this data set, right? And then they can choose the target column. So here we are just kind of listing the files present in the data folder. So this doesn't have to be a case. So instead you can also link this drop down to Azure storage account, or you can also link this to an S3 bucket, so that let's say you have like 10 files in that particular S3 bucket, and we list that, import it and kind of train it on that. So that's like more advanced way of doing this, but it would be an interesting thing to do. So that's how you can think about this. So now maybe let's understand this code of Streamlit app as well as this YAML utility thing. So first we are importing the dependencies such as the OS module in order to access the files, and we have of course the Streamlit thing, and we have the Streamlit option menu, sklearn and sgboost. So here we are importing the necessary models, and then we have YAML utility, which is like the custom file that we have over here, where we are kind of building the functions that we need, like reading the data, pre-processing the data, training the YAML model, and finally evaluating it. So these are the functions that's present in this YAML utility. And I've also given this requirements.txt file. So I'll show you this GitHub thing as well. So you have this requirement.txt where I have listed down all the required libraries. So you can just do a pip install of this requirements file in order to install this. So this is the one, and just go to the terminal if you are like, let's say, using PyCharm, or you can also use like Anaconda Pro. But I would suggest you to use PyCharm, as it's better for accessing the terminal, as well as like it's good for kind of using the debugger. So here I'll just do a pip install -r requirements.txt. So you might already know the purpose of this. So this would kind of read the requirements.txt file and read kind of install all the required libraries and the specific versions. So I've already installed all these libraries. So it says that requirement already satisfied. So I'll just clear the history of the terminal. Now let's come back to this main.py thing. Okay, so we have imported all the dependencies, and then the next step is setting up the working directory. So this is our project directory, right? So it says code prep March _23. So this is the kind of project, and within this src we have this main.py file. But when we kind of run this Streamlit app, this is not the default location on which this code runs. So we won't be able to access this data directly. So in order to access it, you may have to copy this absolute path, like the exact path in my machine, and you have to paste it. But if I do that, if you run this code on your system, you have to like manually change that. So it's basically like we would kind of prefer not hard coding the path, so that I'm kind of trying to get the directory name from this file itself. So what I'm doing here is using this os.path.directory name, os.path.absolute path of file. So when I call this file, what this basically does is it kinds of looks at this file main.py and finds like what's the directory of this. So that's what you would get here. So in this os.path.absolute path give the path of this file, and directory name gives the directory in which this main.py file is present. So it's basically you would return this src folder. So I can also show you this particular code from this check.py. So this is also in the same directory. So I'll maybe first import os, and in the next step I'll just kind of print this working directory, and now we can run this. So this would give this like directory path, directory name, so src. So we need this in order to access this data. So in order to access this, we need to go to the parent directory of this src. So parent directory of src is nothing but code prep March 23. So that's what I'm doing here. So we are doing this like parent directory is equal to os.path.directory name of working directory. It's just like previously we got the directory of check.py file. Now we are getting the directory of this src directory. So it's like just a simple use case. Now I'll just like copy this parent directory and paste it here, and now let's run this. So this now gives you the project directory, which is nothing but code prep March 23, right? And now later I can just, from this I can just add this data path in order to access the files. So that's the reason we are kind of adding this working directory and parent directory thing, and the purpose is just to not hard code the directory folder, but to kind of get this in the runtime, like so that even if like anyone runs this code, they just need to have this data folder. They don't have to change any path in their kind of code files, which is like not recommended to have these hard code path values. So that's why we are adding this parent directory. So later we will kind of add this data subfolder to this. So that's the idea. And the next thing is we are setting up this page config. So st.set page config. So we are setting up a name for this page, which is automate.ml, and we are giving an icon which is like a brain icon. So you can just go to Google and search Emojipedia, or you can just search like brain icon or any icon of your choice, and layout is centered. So you have two options. One is centered layout and the other one is like wide layout. You can maybe try both. So wide would just give you like this increased screen utilization. You can just try that out as well. And in order to run the Streamlit app, you just have to type in your like project directory Streamlit run. You have to run this main.py, but my main.py is within this src folder, right? So for this I need to say Streamlit run src / main.py. So let's say that in case if you have a directory name that has space on it, in that particular case you need to put double quotes and just say, let's say you have a folder called as source space underscore code and main.py. In that case you need to kind of enclose it within double quotes, right? So that's something you can remember, but we don't have that here. We don't have any space in between the names, so I can just say src / main.py file. So this will start my Streamlit application, and here you will see the name of the name of the page, which is automate.ml, and the brain emoji. So that's what we have configured here. So the next thing is like setting up the title for this page, which is no code ML model training, which we are seeing here with this robot emoji. The next step is getting the list of files in this data directory. So as I said, here we are getting the parent directory. Here the parent directory is nothing but this project directory of code prep March 23, and from there I'm accessing this data directory and using this list dir. So this list dir basically lists all the files in this directory. So here I'll come back to this check file and kind of run this dataset list. So this would list all the files in that particular directory, which is art CSV, diabetes excel, and diabetes CSV. So these two are basically the same files, but I want to show that this code works for both Excel file as well as CSV file. So that's the purpose. And then we can come back here, and now we kind of pass this list to this select box. This st.select box is what we are creating here with this choose an option thing, and here we are saying like a statement called as select a dataset from the drop down, which is displayed here. So this is how you can create this select box, and the user can select a single file from this drop down. So we have this, and index is equal to none. So index is equal to none means like by default there won't be any file selected. But if you use like index is equal to a particular number, that data set will be kind of chosen by default. So that's that purpose. As I said, the interesting thing would be to connect this dataset list or this select box to an S3 bucket or like storage account blob in order to list the files present in an S3 bucket. So it's like the user can, let's say there are like 100 files present in an S3 bucket. So out of that, the user can select a particular dataset and they can train the model of their choice. Or we can also configure this such that we kind of connect this to a database and list all the tables present in a database. So once the user has clicked it, instead of reading it from the folder, we are going to load it from the database and kind of like train our model. So that's the purpose. So this actually this step should be highly configurable. So you should be able to get it from different cloud sources or even database. So that's like an interesting thing that you can definitely work. And now the next step is reading the dataset. So this particular thing will basically return you the selected dataset. So let's say that the user has selected this diabetes.csv file, right? So this dataset variable would get the name of that particular file, and then we are reading that particular dataset. So here we have this function which comes from this YAML utility thing. So I'll go to this YAML utility where again we have imported all the required dependencies, and we are doing the same thing of finding the parent directory so that we can access this dataset files. So we have this read data and it takes in the parameter which is nothing but the name of the file that we should read. So here let's say the user has selected like diabetes.csv. So that's the parameter that we are passing in this particular step, right? So let's come back here. So in this YAML utility, I have this file path where I'm kind of substituting it with this f tag. So we have this parent directory slash data slash file name, which in this case would be diabetes.csv. And here we are checking if that file as an extension of CSV or it kind of as an extension of Excel. So based on that, we are using this read CSV or read Excel and then returning this data frame. So basically this function would take in the name of the file and it will read that and return it as a data frame. So that's the purpose of this read data function. So that will be loaded in this variable called as df. If df is not none, that means when we load this data, so when the user has selected a particular data set, right, we run this kind of next set of lines. So this set of lines won't run if the user hasn't selected anything, because before the user has selected something, right, so df would be none. So you won't see any of these things. So here we are basically displaying the head of the data frame using this st.dataframe. So st.dataframe function, which is streamlit.dataframe, is used to display a data frame in your screen. So here I'll go here and choose this diabetes.csv. So now this will automatically read this file and display the head of this data frame. So that's what we are seeing in this st.dataframe. Again, if the user hasn't selected anything, if I refresh this and we don't select anything, so df value will be none and this if block won't be executed at all. So that's why you're not seeing anything here. But once we have selected something, we are seeing this table which is df.8, and then we are creating like 4 columns. So here we have this st.columns, and with that we are creating this 4 columns, and now we in this we are going to let the user select a target column. So what's the target is going to be? Let's say that again the purpose of showing the data frames sample is to let user understand the columns present in the dataset and like kind of make a decision of what's the column or what's the target column is going to be. So in this case the target column will be outcome, and now we are just focusing on like classification models, but again you can also work on adding like a similar web app for regression models as well. So that's again like, it would be an interesting addition, but you can definitely try that out. So here we have the scalar types. So we are going with like 2 scalar types. One is standard scalar and the other one is min-max scalar. So you would have kind of already know if you have like kind of did any machine learning courses. There are 2 kinds of, mainly there are 2 kinds of scaling. One is standardization and the other one is like normalization. In standardization, we kind of scale the data such that the data is like kind of normally distributed so that it has this mean of 0 and standard deviation of 1. But min-max scalar is when you want to normalize it so that the values lie between 0 and 1. So the max value will be 1 and the minimum value will be 0. So let's say that we are kind of letting the user to use this, but again if you want you can also just keep this scalar to be standard and don't let user to choose this, as this is like something kind of like unique, and they may not have this idea, so that you can make the choice instead of letting the user. But in this case I have added it, so they can just go with either standard scalar or min max scalar. So that's in the second column thing. And then we are creating this dictionary. So here we are going to display this models. Like for now I've added like 4 models, but just work on adding like more classification models. So we have this logistic space regression, support vector classifier, random forest classifier, and so on. In order to dynamically use these models, so what I have done is I have imported all the models from their respective libraries. So logistic regression, SVC, support vector classifier, random forest, and XGB classifier, and putting that in a dictionary with the key of the model name. So here we have this logistic regression, and we have this exact object of logistic regression model. Here we have the key to be support vector classifier and the object which is SVC parenthesis, and so on. Right. So that like once the user has choose a particular model, we kind of pass this value, which is this object. So maybe you will understand this later, but yeah, just understand that we are creating a dictionary with key as the description or the name of the model, and value to be that exact object that we are loading from the library. And the next step is we are creating these columns. So here we have the select boxes and text boxes, right, in 4 columns. So this is the first column, second column, and so on. So we are creating these 4 columns from here. So this column 1, column 2 comes from this st.columns that we have created. And with column 1, first we are creating a target column. So here we are creating a select box where we are saying that select the target column, and the options that we are giving in is nothing but the list of columns that the user has selected. So in this case, if you see this, the user has selected diabetes.csv. So here we would pass a list of all the names of this particular data set. So here we are seeing like pregnancies, glucose, and so on, right? So that's the thing that's present here, pregnancies, glucose, and so on. So here we know that the target column has to be outcome. So that's something the user can select. And next one is like the scalar type. Scalar type, we have kind of hard coded the list, which is standard or min max, right? So we are passing that. And if you open this drop down, you will see either this standard or like min max. So the user can select it. Next is passing in the keys of this model.dictionary. So when you kind of call this model dictionary.keys, so even I can show this to you in this particular check.py file. So let's say that we have this model dictionary, and here we need to import like all the models. So I'll again copy all these model names. We don't need Streamlit option menu, so I'll just like remove this. We don't have like multi-page app, so that's not required, right? So we have this, right? So when I print model dictionary dot keys, this will print the keys which is like logistic regression, support vector, and so on, right? So we have these names, but when I kind of get the values, it will print this logistic regressions, right? So basically we are getting this keys in a list and passing that to this particular select box. So that's what is happening in this third column of selected model is equal to st.select box and select a model, and this is nothing but the list of the keys of this dictionary, which has like logistic regression, support vector, and so on. So just try to add more models to this. And finally we are creating a text input where the user can give the name of the model, and with that name we would save a pickle file in this trained model directory, so that again we could kind of create another predict page. So for now we are not doing that, but again you can kind of work on creating this predict page where again the user can select a particular trained model and given some input and get a prediction out of this. So that's this that's about this model name. So that's about it. So now maybe I'll choose as outcome standard scalar logistic regression, and model name, let's say it's diab logistic regression model, right? So let me name this as diabetes logistic regression. So to this we would have this add dot pkl to that. So yeah, that's not complex at all. So the next step is once the user has clicked in this train the model, we are doing like few steps. One is pre-processing the data and training this data set using this train model function, and finally evaluating it and getting the accuracy and displaying it. So these are the steps. Now let's understand this. So this pre-processed data set. So here we are doing a bunch of steps. We kind of check if there are any missing values. If the missing values is present in a numerical column, we are going to replace it with mean. If it's missing in a categorical column, we are going to replace it with mode, which is nothing but the most frequent appeared value. And we also kind of do this one-not encoding on the categorical columns automatically. So all this kind of should happen automatically without any manual intervention, so that like this step is like kind of automated for any data sets. So if you see this pre-processed data, we are passing in data frame as one parameter, target column, which is the one that is chosen by the user, and we also have the scalar type given by the user. So we are passing all those things here. So pre-processed data, we have df, target column, and scalar type, and this would return x train, x test, y train, and y test. So here we have this YAML utility thing. We have this x is equal to df dot drop target column. So the target column given by the user will be dropped and it will be stored in this y. Now we are separating these numerical columns and categorical columns. And again, the important thing here is we are kind of having this as an assumption, or you can think about this as an hypothesis, where we are saying that numerical columns will have number as its data type. So it can be an integer or a float data type. But if it's like category, it should be like object or category data type. So this particular categorization of separating the numerical and categorical columns won't work if the categories are already if they're like already label encoded. Because let's say that we have a column of gender and we have already encoded the male values to 0 and the female values to 1. In that case, the column data type would be number, right? So that won't be considered as a categorical column. So it would be considered as a numerical column. So you can again think about how we can kind of rectify that. One option would be to let the user choose which columns are numerical and which columns are like categorical. So you can definitely try this out. But for this base version, we are just like saying that check if it is a number. I mean, basically, if the data type is integer or float, if that's the case, consider it as numerical columns. If not, if it is like an object data type or categorical data type, we are going to say those are categorical columns. So X is nothing but the data that we have segregated except the target column. So from that, we are getting a list of numerical columns and a list of categorical columns. So if there are no numerical columns, so let's say that all the columns are categorical, then we are not going to do the process of standardization, right? Because standardization we would do on numerical values of numerical columns. So basically, if there are no numerical columns, we are going to pass it. But that won't be the case of most data set. So we are saying we are putting this else condition where if there are some numerical columns, we are going to split our data, split our x and y into training data and testing data, x train, x test, y train, and y test. And saying that use this train test split function, xy test size of 20%, random set of 42, just any random set, you know the purpose of it, just for reproducibility, right? Yeah. And now we have this impute automatic like imputers. So where we have this num imputer and we are using this simple imputer from sklearn.impute, right? And here we are going to say, that this else would run only for the numerical columns, right? So when we have some numerical columns, so we have separated the numerical columns already, and we are going to impute it by mean. Basically, let's say that you have a data frame that has 10 columns, and out of that 7 are numerical columns. So in those 7 columns, we check if there are any missing values. If there are any missing values, we are going to replace it with mean. So we are doing a fit transform and just a transform in the test data as we would generally do, so that we don't have any data leakage. So it's like you would find the mean of the training data, replace the null values in your training data with that mean value. You would replace the same mean values in your test data. You won't find the mean separately for your test data, right? So that's the thing. And then we kind of here we have this, right? So the user can either select standard scalar or min max scalar. If the user has selected standard, we would load the standard scalar. If they have selected min max, we would select this min max scalar. Again, as I said, this can be a decision you can make as well. Like, you don't have to give this choice to the user, as this is like a bit peculiar or like too technical, right? So again, you can just keep this to yourself, but I just wanted to show this to you. So from sklearn.preprocessing, I'm importing the standard scalar and min max scalar, and also one not encoder, which will be eventually used. So a particular scalar will be loaded based on the user's input. So we either load standard scalar or min max scalar to this variable called a scalar. Then we apply the scaling operation only to this numerical columns. Again, we do a fit transform on the training data, numerical columns of training data, and just do a transform on the numerical columns of test data. So the processing of numerical column is done. So now we have like either standardized or normalized inputs on the numerical columns. The next step is doing like similar processing for categorical columns. Again, there is a chance that your dataset may not have a categorical column. They may not have string values. In that cases, we check the length of categorical columns. So categorical columns is just nothing but a list of the columns that are objects or categories, right? So if there are no categorical columns, we are not going to do any of these steps. So we are just going to pass this, and if in case there are some categorical columns, right, we are creating this simple imputer. Again, if there are any missing values in this case, we are going to replace it with most frequent values, which is nothing but the mode value. Previously we were replacing it with mean value, but now we are kind of replacing it with most frequent values, and again doing a fit transform on the training data's categorical columns, and doing a just a transform on the test data's categorical columns. And the other step is like doing this one not encoded thing. So I hope you know by this point what one not encoding is. It's like kind of exploding the categorical columns. So maybe you can kind of check that, but this is like the code to do it. So first we kind of split the numerical columns and do the one not encoding only on the categorical columns. So if you see this, right, so we are fitting and transforming it on the categorical columns and just transforming it on the xtest and storing those specific columns. So we are basically storing the encoded categorical columns of training data to this extra encoded, and encoded categorical columns of test data to this extra encoded. And then we finally create this data frame where only the encoded columns are saved. So this encoded.get feature names would basically like give you the updated categories. Let's say you have 3 categorical columns, and again if you do a one not encoding, you would definitely have like several columns, right, based on the number of categories present in those columns. So we are getting those column names and creating a separate data frame for extrain and xtest only the encoded values, and later we are concatenating it with the other columns. So basically we are dropping the previous categorical columns which are not one not encoded, and then we are just like including the columns that are one not encoded. So it's basically like, let's say you have a column, maybe I can just show this from this data frame. So let's say that this insulin column is, or you can just consider this outcome column, right? So which is a categorical column, but we are using as a target. So I can think about it. So you have this outcome. So once you do this one not encoding, you would have 2 columns saying outcome underscore 1 and outcome underscore 0, right? So we are going to drop this outcome column and add outcome underscore 1 and outcome underscore 0 to this previous data set. So that's what is kind of happening in this particular case, where we are dropping the categorical columns, which would be this outcome in this case, and adding this extrain encoded, which is that outcome underscore 1 and outcome underscore 0 thing to both training data and test data. Again, in this case, this is a target column. So basically we don't do this on target column, but I'm just like giving you an example. So we are doing this one not encoding. So if you're not sure about it, please kind of read some articles on one not encoding. So this is like a critical step that we do in the data processing. So once we do that, we return the xtrain xtest and ytrain ytest. So that would be the output of this preprocessed data function. And then we have this kind of like model to be trained model dictionary. So this is nothing but kind of extracting the exact model object from the user selected one. Maybe I can show this to you here. Okay, so let's say that this is the dictionary, this is the list that goes in, right? So the user has selected random forest classifier. In that case, what would happen is I would say let's say selected model or something like that. Selected model is equal to model dictionary, and within this key the user selected is random forest, right? So when I paste this, this would give me this random forest classifier as the value for this variable, which is selected model. So print this selected model and let me run this. So this would say random forest classifier, right? So that's what we are doing. So once the user has selected a model from this dictionaries key, this dictionary key is something that the user have selected. So from that we are taking the exact model object and loading it to the variable called as model to be trained. So this model to be trained is then passed on to this function called as train model. So if you see this train model function, right? So these are the inputs it requires. One is like xtrain, and then we have the ytrain, the labels, model, and the model name. Model name is nothing but the name of the pickle file that we need to save. So these are the parameters, and model to be trained is the one that the user selected, but not just the string name, but the actual object. So this is the reason we are kind of storing this in a dictionary, so that we can dynamically kind of get the specific models that the user want to train. So that's about it. So once we kind of call this, these are like simple steps, the one that we usually do. So we do this model.fit on xtrain and ytrain, and then kind of save this train model in the parent directory. Parent directory already we have kind of discussed. So it's nothing but this project directory. From the time, instead of going to the data where my data is present or the source folder, I have this folder called as train model. So here I'm going to save the model name that the user is giving. That comes from the fourth text input, which is in this case diab log rec, right? So, and then we are saving it as a pickle file and dump it and then return the model. So once the model is returned, it's stored in this variable model. And finally, we have this evaluate model function where we kind of pass this model x test and y test and predict the value for x test. So all these are stored in ypred, calculating the accuracy score using this y test and ypred. So I hope you are clear about this, because these are like simple steps of evaluating the model. So we are just finding the accuracy, rounding it to 2 decimals, and then like returning the accuracy score. The other thing that you can include here is probably like adding a classification report, putting that to a data frame and displaying it on the Streamlit. Or you can also kind of find the precision recall FN score separately, or even you can just kind of find the confusion matrix displayed, like all those evaluation thing you can do. So that we are getting here. So we are getting the accuracy basically in this evaluate model, and then displaying it using this st dot success test accuracy string of accuracy. Because this st dot success, maybe I'll click this train the model. Basically this will do all the data processing, imputation and all those things and print the accuracy, right? So this text and string values, but the accuracy will be numerical values. So I'm kind of converting that to a string and concatenating to this test accuracy, which is what you're seeing here. So this is how you can automate this. And again, this is a very simple version of automating this, but there are like so many things that you can do. Just think about it, right? You can configure this to take data from different sources, like an S3 or an storage account from Azure or even a database. And now you can kind of add several pre-processing steps that like the user can select what's the categorical column should be, what's the numerical column should be. You can even add like an option where the user can select like the hyperparameter values. So let's say that you have several other text fields or the numerical inputs where the user can select the hyperparameter for the selected model. So it's basically, the idea is to not do the coding and just look at this web app and just given like these basic information, and we do all this coding in the backend and just give them the result and the train model. So here the name of the model is diab log reg, right? So if you see this train model, it will automatically be saved. And the other enhancement that you can do to this web app is like create using the Streamlit option menu. So I've already done that in several videos of mine where I've used the Streamlit option menu in order to create multi-page Streamlit apps. So you can kind of create a prediction page where the user can select trained model. So let's say that I select this art.csv, and let's say target will be the target column standard scalar, and let's say we use this XGBoost classifier, and let's name this as art XGB and train the model. So these are smaller data sets, so it's not taking that much, and here we are seeing the test accuracy of 0.82. You can also kind of display the training accuracy to see if the model is overfitting, and all these things you can think about and include it. And so we have this art.xgb, right? So similarly, you can create another page where you can list the trained models here, and the user can select a trained model given a input data and predict like the output required. So that's something which is like a really good enhancement. So I would just want you to try that and see like how that's coming up for you. So I hope everyone is kind of clear about the things that we have discussed, and again you can work on improving this a lot and building like a more consolidated application where we kind of automate all these things. And again, the main purpose of this is to let someone who doesn't kind of know this process of coding or training an ML model, just they can choose a data set given some basic values and they can train the model. So I hope everyone is clear with the code. So again, as I said, I'll share the link of this particular repository. Please kind of go through this and try to do this by yourself. So I hope this is useful for you, and I'll see you in the next upload. Thanks for watching.